Okay, today we are talking about gravity and black holes. Okay, so black holes are giant stars 25 times bigger than our sun, and they are burning up all this hydrogen and which is exploding and counteracting gravity. Then, upon their life's end, the hydrogen runs out. Gravity compresses the matter, and in the very end, the compression it continues and continues until uh, the volume of the star is well is like an incredibly dense idea. Compressing mass squeezes space out. Okay, now imagine squeezing a lemon. All that juice is gonna come out. Now that's what gravity does to red giants, okay? Gravity squeezes those stars and all that space is gonna come out. As the diagram shows here, the the mass uh, there's less space the more squozen the star is, because uh, all of that space has left the star until we reach a singularity where there is absolutely no space in it. It's 100% mass, people. Idea: displaced space surrounds the star. Okay, so what do you think will happen to that extra space that came out of the star? It's gonna stay nearest to the star. So you see 50% extra space that has been squeezed out of that star in the first image. In this middle image, there is 75% extra space. And then you go to the singularity and you find 100% extra space surrounding this 100% massive black piece of matter. Idea: extra space becomes compressed. Okay, so that displaced space plus the regular space that is there means that there is too much space, right? So what do you think will happen? If there's too much space for the area, there has to be cramping or compression. Uh, so we see in the first image, there's 50% extra space, so there's 50% compression. That's our logic. The middle image, 75% extra space, 75% compression. That means we'll talk about what that means. And then here we are in the black hole. Uh, there is a 100% extra space surrounding the singularity, and there is 100% compression. Let's think about that. Idea: gravity equals downward space pressure from compression. Okay, so we've arrived at our black hole. We have the singularity in the center. Uh, that is an area of 100% density, 100% mass, uh, and very, very little volume. And surrounded, the blue area represents the event horizon. The event horizon is the area of space where the compression of space is 100%. So this means that gravity, uh, which as we just stated is downward space pressure, is 100%. This means that all that blue space there is pushing with 100% force towards that black dot in the center. This means that nothing can escape. You cannot escape uh, uh, an area with 100% gravity in theory, right? It if the gravity was 99%, then yes, you there is a 1% chance you can escape it, but not 100%. This is why not even light can escape it. The lightest thing in the universe, light, cannot escape 100% gravity. It's not doable. Okay, so let us talk about that singularity, the black dot in the middle. That is a round piece of mass that is full of damaged atoms. Imagine a house crushing it, and you have the walls crushed against up each other. That's what's going on there. The atoms have been crushed. There is no space inside those atoms, and so you have the atom walls. You have the maybe the electrons, protons, but they're not the same. They've been flattened. They're all damaged. Why? Because black holes are dead stars. Death is ugly. It, it's ugly with every species. It's also ugly with stars. And that's what happens. That's how gigantic stars die in black holes. However, the it's not forever. They apparently, I've read or heard, they radiate some energy, and eventually they the the singularity goes away, and I guess new life begins in the cosmos.